This is a collection of stars, and I always like to start out my presentations with this image because this wasn't even supposed to be a public image. This is a calibration image for a new camera that was recently put on the Hubble Space Telescope, and it was taken to see if the new camera worked well. But this image would tell us that, in fact, the new camera does work very well, don't you think? This shows in one globular cluster, as we call it, of stars, the variety of stars that you might not see, especially in a city. If you go out on a starry night, you might not know it's a starry night because of our light pollution and all the other problems we have made for ourselves in terms of seeing the heavens. But if you can get above the clouds, as we can with space telescopes or with telescopes on mountaintops, so forth, we can see a lot more. And this particular image, I think, takes us into this realm of the huge, the enormous, the magnitude of the universe. I can throw out numbers that there are hundreds of billions of stars in our own galaxy and hundreds of billions of galaxies. That doesn't mean a lot to me anyway, unless I can see a visual image of it. This is one globular cluster of stars in our own galaxy, and because of the precise angular resolution of the Hubble Space Telescope, you can see star separated from star, even in this very dense cluster. And you can see that star differs from star in splendor, as the Bible actually says. And in here we see red stars, blue stars, yellow stars, green stars, stars of different brightnesses. Shows you the huge variety. Stars fill up entities that we call galaxies, such as this one. Spiral galaxies are full of gas, dust, and between all that gas and dust and within it are hundreds of billions of stars. And over the years, the rotational motion of galaxies and the tidal forces within can create interesting shapes, such as these spirals. The glow inside the core of galaxies is really a combination of the light from hundreds of billions of stars embedded within. We need to start thinking for this conference about these different perspectives of how faith and science might talk to one another. So I thought these were a couple of good quotes. Freeman Dyson is a very famous physicist, and he said, "Why are we here? Does the universe have a purpose? Whence comes our knowledge of good and evil? These mysteries and 100 others like them are beyond the reach of science. They lie on the other side of the border, within the jurisdiction of religion." So he says that there's kind of a border between the two, but that science can't answer all kinds of questions. And Francis Collins, a famous geneticist of our day, says we cannot discover through science alone the answer to the questions, why is there life anyway? And why am I here? If we look to Scripture, most often when we talk about nature, and in particular for this talk, the heavens are mentioned in context of praise for their creator. So the Scriptures don't delve into the details of science, even as much as we sometimes try to make them do so, but we do see lots of praise in there. And so this familiar psalm sings out what those of us who enjoy looking at the night sky realize every time we look, that the heavens declare the glory of God, the skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge. There's no speech or knowledge where their voice is not heard, or in some translations it says they have no speech or language. Their voice is not heard, and yet their voice goes out into all the earth, their words to the end of the world. There's something about the heavens. There's something that the heavens are speaking, in a sense, to us, and it's our job, both through science to find out the scientific truths that we're learning by looking at the universe, and through our faith and philosophy to find out the other things that we can glean by looking at the universe. And we need to put our minds to this task. All right, that's a beautiful psalm, the heavens declare the glory of God, but exactly how do the heavens do that? And so I thought we might explore that a little bit this evening. How does that happen? For some, it's just a matter of contemplation and contemplating the worlds that God has made create a sense of awe, humility, and worship. The famous hymn, "How Great Thou Art, O Lord my God, when I in awesome wonder consider all the worlds thy hands have made. I see the stars, I hear the rolling thunder, thy power throughout the universe displayed." Then sings my soul, my Savior God, to thee, how great thou art, how great thou art. A natural expression of response to the beauty of nature. But what about this perspective of faith? Does the universe or does science prove or disprove God? How do these things fit together? It's a confusing conversation in our society and in our conversations today in the church as well. So I think it's helpful to remember that science, which I love as a scientist, but science is a tool that's limited to answering certain questions for which it's designed to address. So science is very good for exploring questions of how do things work in terms of physical cause and effect, and when in terms of natural history, and why in that sort of physical sense. While faith mainly addresses these bigger questions like why, capital W, is there a purpose for all of this? Is there a God? And how should we live? This kind of thing, those bigger questions in which our science is embedded. Not everyone looks at nature and sees a natural response of praise to God, and so some are more bewildered by nature than anything else. And this quote from physicist Steven Weinberg points out that to him, the more the universe seems comprehensible, the more it also seems pointless. And I think that's also a valid response by looking at some of these things that we see both in the huge size and time frame of the universe, and also what we see in the biological history of the Earth, and what we see even going on today. It can seem confusing, pointless. Those responses are natural as well. I'm going to skip over some of this in the interest of time. So what attributes of God's glory? We've just said the heavens declare the glory of God. So given that science answers certain kinds of things and our faith addresses different kinds of things mainly, what attributes of God's glory can we glean from looking at the heavens? And so I think these things we glean not from strict scientific deduction, but from inference through our lens of faith. So I do believe that there are reasons to believe in God, and if you have that faith, we can learn something about the nature of God by what we see in the heavens, but not through science itself. What do we learn about the heavens, and how do we do that with scientific tools? Well, we use telescopes. This is one of them. This is the Hubble Space Telescope in orbit around the Earth, and it's about the size of a school bus. It's whizzing around every 90 minutes right now and sending down data, and it's been doing that for 23 years. Telescopes come in different places, different wavelengths of light. They work in concert together. We have telescopes on the ground. We have multiple telescopes in space. We have radio telescopes, infrared telescopes, optical telescopes, X-ray telescopes, ultraviolet telescopes. We have all kinds of things. I'm not giving you a complete list. They work together like a symphony orchestra with the different instruments having different sensitivities, and working all together, they give us a much richer picture of the universe in which we live. And what we're finding out is that our universe is not just stagnant, that we know there's stars and planets out there somewhere, right? But they're not just sitting there. Our universe is active and fruitful. And so knowing that from science, through lenses and the eyes of faith, we could say that maybe that tells us something about God's glory, that God has an attribute of creativity or power or beauty or all of these things. So how is the universe active and fruitful? Well, for one, stars come and go. This is the beautiful Orion Nebula. So I point this out because I studied Orion for my dissertation work, for my thesis. I studied it with radio telescopes where you could actually see behind this colorful glow here and into the dark cloud where baby stars haven't even turned on yet. We call them protostars. But here in front, you see this bright swirl of gas that's lit up by stars that have just recently formed. Massive stars form quickly. They form when a ball of gas in this turbulent material becomes overdense for a moment and feels its own weight and will just collapse under gravity. And if there's enough of it, there'll be enough pressure in the core of that little blob that the hydrogen will start fusing into helium, and that reaction releases photons of light. Eventually that light escapes, and if it's powerful enough light, it will hit the atoms of light in the surrounding gas and light it up through a process called ionization. So that colorful gas all around is because of the photons coming out of newly formed stars, and it is beautiful. It's also a signpost of the activity of continuing formation of stars. Astronomers will look over whole galaxies for these bright spots where this ionization is occurring, and they know that's a hot spot of star formation. On the other end of a star's life, that's also beautiful and active. Stars begin to run out of fuel at some point, and they will start to release their outer atmospheres in this instability, and that can be quite lovely as well as dynamic. This is an old star releasing its outer atmosphere in a kind of bipolar fashion. Someone thought it looked like butterfly wings, so this is called the butterfly nebula as the gas is moving out from the core of this star. These regions, as I mentioned, stars, gas, fill up the volume of galaxies. Galaxies are made up mostly in volume of stars, of gas and dust. But of course, embedded within all those gas clouds and within the dust and between it all are hundreds of billions of stars. I love this particular galaxy because I chose it at random out of the archive of the Hubble Space Telescope. And even in its randomness, it's a beautiful spiral pattern. And you see some background galaxies here too that are also lovely. And I generally point out to audiences that the astronomers who also thought this was lovely named it NGC 1309 in the poetic sense that astronomers have. But given that sense of inspiration, we can imagine our own beautiful Milky Way galaxy that looks something like this. We can't get all the way out to take a full picture of it, but from inside we can look around and infer that we also live in a spiral-type galaxy like this, and our sun is one star amongst 200 billion stars, and our star is about 2/3 of the way out along one of the arms there. Galaxies themselves are not stagnant. This is a galaxy right here. But what's going on with this galaxy is that in the core, there's something very powerful. A supermassive black hole has formed there. It's a conglomeration probably of many, many stars that themselves have become black holes in their olden age. They've come together, created this enormously dense region where light itself cannot even escape because the gravity is so powerful. But around that region, material falling in can get caught up in magnetic fields and ejected at speeds close to the speed of light to distances far beyond even the region of the galaxy itself in these bipolar lobes that are just spectacular. This is a very active galaxy. We believe our own Milky Way has a black hole in the center as well. We can tell from the motions of stars around the core of our own galaxy, but it's not active in this way. We don't see these majestic lobes being ejected from our own galaxy right now. Galaxies can merge if they get too close together, being pulled together by gravity. And in fact, it looks now like most galaxies from our own epoch have gone through several mergers to get to the point of their size now, including our own Milky Way. And we can especially see mergers as we look back into the history of the universe by looking far into distant space where light has taken a long time to travel to us. This is what two galaxies look like as they get close. And this is what they look like when they get even closer. This is another pair that's farther along in the merging process, and all the turbulence has stirred up these bright areas that I mentioned to you before where stars are starting to form very, very vigorously. We call them starbursts. By the way, our own galaxy is on a head-on collision course for Andromeda, which is our nearest neighbor spiral galaxy. But rest assured, when these things merge, most of the stars don't collide with one another. It's just a turbulent mess up of the spiral structure. So we should be okay. We just have a very different vision in the night sky at some point. And it's not going to happen for a few, I think we've got several billion years. So we're okay. All right. Let's look at that cluster of stars as we did before. Now, this is supposed to be an animation that I was promised would work on this. Ah, there we go. A rather violent constellation, but we are going to move in from this broad image taken with a telescope on the ground to this globular cluster of stars. And then we're going to transition over to that image as seen with the Hubble Space Telescope I wanted you to see the context of those beautiful stars and where they fit in the big picture. And that's always important when you see a small thing, to see where it fits in the large scale. People like to see that twice, so let me see that. So again, the bigger field of view is something we get from a different kind of telescope. Come on. It's not going to do it for me again. Let's try that again. Here we go. This is the Centaurus region of the sky. We're zooming in on Omega Centauri, or Omega Cen as it's called, which is one of these old globular clusters. Most of the stars in here are very old. And there we have it. All right. Now, what's neat about stars? Lots of things are neat about stars. Our sun is a star. But in astronomy right now, we live in a very exciting time because we're discovering something that we imagined for a long, long time, but for the first time ever in history, we're actually detecting them, and that is the presence of planets orbiting stars other than our sun. So we've known that we have planets orbiting our own sun, but it's always been sort of speculation and science fiction as to whether there are planets orbiting other stars. And just within the last couple of decades, we've started actually detecting planets around other stars. That's a very difficult process because planets are very small, they're very dim, they're hard to see. And we typically find these planets indirectly by seeing how they block out part of their star's light as we look at the star every orbit, or they cause the star to wobble through that mutual gravitational tug. This image is an artist's conception of a real planetary system detected with the Kepler Space Telescope. And in this case, the star has 6 planets that have an orbit that would be interior to our own orbit of Mercury if it were in our own solar system. We have discovered many, many systems like that just within the past 2 or 3 years for the most part. It's a very exciting time. And so you start to think about it. There are 200 billion stars in our galaxy, and only one of them is our sun. This is a ground-based telescope image of the center of our galaxy, so you see a lot of stars and a lot of dust in there, and try to imagine how many stars there are. So you start to wonder not only if there are other planets in the universe, the answer to that is yes, but is there another Earth out there, and could there be life out there? That's a question that we may be able to answer with science very soon. We are actually gathering data on this, even though this type of question has been speculated on for many centuries. Even Greek philosophers such as Epicurus thought about this. He said, there are infinite worlds, both like and unlike this world of ours. We must believe that in all worlds there are living creatures and planets and other things we see in this world. Of course, they use the word world a little differently than we do. It's technically difficult to find these planets, as I mentioned, because stars are 1 billion times brighter than planets that we're looking for. So that's like looking around a lighthouse in the glare to try to see something very small hidden in the glare, like a firefly. It's hard, but you can do it. And the technology is growing at a very rapid pace. So this is an example of a recently imaged planetary system. The starlight has been blocked out by something called a coronagraph. And those 3 planets have emerged into the image where you can see them. Now, these are not Earth-like planets. They're very large gas giant planets. They're very far from their parent star. But it shows you the techniques are getting better and better. And we want to answer questions like what fraction of stars in our galaxy harbor potentially habitable Earth-sized planets? That's what we really like to know. This is an artist's conception of the Kepler telescope that's staring at 150,000 stars to see how many of them dim a little bit periodically due to the transiting orbits of planets. And from that, this telescope is giving us statistics as to how many stars have planets and what those planets are like. The discovery rate, mostly through these indirect methods, has skyrocketed. So this little chart shows you from the year of discovery down here, starting around 1990, and up to today, how every year, how many of these things have been detected. And it started from 1s and 2s down in here to dozens up in here. And this chart only goes to March of this year. And even since then, we've had a lot more discoveries. So you see the sort of exponential rise in the number of planets being detected every year. Some of them now that are being detected are even smaller than Earth or Earth-sized. These are artists' conceptions of the Kepler 37b, C, and D, which are planets actually detected through this Kepler mission. Although we don't get pictures of those planets, we get their sizes, so you have to imagine what they might look like. But this is embedded in this image where you can compare them with the size of the Moon, Mercury, Mars, and Earth, and see that we're actually finding planets smaller than Earth at this point. We're even finding planets that exist in what we call the habitable zone, so there might be actually the right temperature where liquid water could exist, and we think life depends on liquid water. So just quickly, all these dots represent planets that have been detected so far, and their sizes: Jupiter size, Neptune size, and Earth size. So most of them that have been detected are bigger than Earth. And the temperature down here, the equilibrium temperature of the planet is here, so most of them are hotter than we think life could thrive on. But some of them down here, close to Earth size and in this green zone, are the right temperature that liquid water could at least stay liquid water in that condition. And one of those planets, if we blow that area up, is actually orbiting a sun-like star. So we're getting closer and closer to finding these kinds of Earth-like planets that we're interested in, and this is a very rapidly developing science. And of course, eventually we want to develop the technology to find out if there's life. So we want to look for evidence of oxygen, water, methane. These kinds of things will tell us if there might be biological activity on the planet. We don't quite have the precise kinds of telescopes yet that could help us look for these signatures on planets close to our solar system. But we are developing that. So it's very exciting, and we need to be able to rule out other explanations if we see these things there. I'm going to skip over some of this. Would Christian theology embrace the idea of life on other planets? Whether that's simple life or more advanced intelligent life? Well, there's a lot of theologians in this room, so you'll have to give that some thought. The answer usually, this has been thought about for centuries actually, and the answer usually comes out to be, yes, we can handle it, but we have to think a little bit about redemption. And C.S. Lewis is one great theologian, and well, philosopher, I should say, and scholar who thought this through and wrote a whole series of science fiction books thinking about the spiritual state of life elsewhere. All right, I'm going to skip over all that. I want to make sure I mention that our universe is absolutely enormous in both space and time. We have our galaxies there, but we actually see hundreds of billions of galaxies. When we look, this is what's called the Hubble Ultra Deep Field. When you point the telescope to a direction in the sky with no nearby stars and just let it collect light for days on end, you start seeing the faintest, most distant objects. These are all galaxies, not stars. Each one of these little blips of light are galaxies with hundreds of billions of stars, and this is just one little pencil beam in the sky. So imagine this extrapolated over the whole sky, and you kind of get, I hope, a sense of the enormous universe that we live in. If our Milky Way looks something like this, and our little sun is 2/3 of the way out in our one little galaxy, and there might be planets around most of the stars in the galaxy, what are we to say about what's going on in all these other galaxies as well? Not only that, but in this image, some of those galaxies are much farther away than others. So we're actually looking back in time, because the more distant galaxies, which are billions of light years away from us, it's taken billions of years for that light to get to us. So we're seeing them as they were toward the beginning of the universe, and we can compare them to galaxies closer to us in space and time, or even our own galaxy, and see if they're different in their morphology and their composition. And indeed they are. You can't even see it in here, but this tiny little red object here, it looks red because of the stretching of space through the travel time of the light from this galaxy. It doesn't look like much as you blow it up, this blob here, but it's the most distant galaxy we've ever seen. And it's shining to us from within a few 100 million years after the beginning of the universe. That sounds like a long time, but I'm talking about within the first 0.7 of the 13.7 billion year history of the universe. This is a baby galaxy that hasn't yet gone through many mergers. It's very small. It doesn't have much but hydrogen, a little helium. It's going to take generations of stars generating heavier elements before we get to a galaxy like our own. And in fact, this is a little timeline. As our telescopes get better and better over time here, we are able to see fainter and fainter things, which means seeing more distant galaxies, which means looking farther back in time from when the light came from those galaxies. So if you think of this as a timeline down here, we're now looking back in time to within the first few 100 million years of the universe, and we can compare the galaxies and proto-galaxies back here with galaxies closer to us and even to our own. And we're hoping that the future James Webb Space Telescope, which is an infrared telescope to be launched later this decade, will even see back before the first galaxies even came together. I'm going to skip over that. The universe is enormous in both space and time, so what does that infer for our quest to know how the heavens declare the glory of God? Well, I'm not sure, except that God must view time and patience and significance differently than we do, because we would probably think of maybe a quicker and more efficient way for things to develop. But I'll tell you that as we look at the stars themselves, we see why we need generations of stars before we can get planets. This is an exploded star, a supernova remnant. And what stars do after they spend their whole lives fusing hydrogen into helium and helium into heavier elements is that they then disperse those heavier elements back into interstellar space so that the next generations of stars have more oxygen and iron and carbon, some of these heavier elements, and they can even form planets in their surrounding disks. And so it seems that our sun is not a first-generation star. It's been several generations of stars to get to the point where we have the heavier elements that we need to have planets and life. It seems that our universe, with these seemingly perfect underlying physical laws that are governing it, shows a progression over time toward the production of heavier elements, planets, and life. I could infer from that, through the lens of faith, a sense of purpose for this maturing of the universe over billions of years of time. I thought for this audience I would mention that there are some, at this point, a little station break, but there are some impediments to bringing science and ideas up like this in congregations, and to even think that they might inspire some kind of worship or contemplation. And so for the rest of the conference, you'll be talking about these kinds of things. But some of these issues are ignorance, and I don't mean that in a condemning sense, but rather people wondering whether science is even relevant to what our congregational life is about. Or distraction in congregations. We've got enough going on. Why do we need to bring in science? Or controversy. Science brings in controversial issues. So goodness, we have enough discord already. Do we need to bring in more? There's always uncertainty. You know, no one knows all the answers. No one knows everything about all kinds of science, and nobody knows how the theology completely works to help us bring science and our faith together. So since there's uncertainty and we don't know how to handle the tough issues, should we bring it in at all? I think the answer is yes. Just leave space for unanswered questions. And then, of course, there's the authority figure question. Which voices should we trust out there? The scientists who are saying one thing, or our religious leaders or these other organizations that seem to be saying other things? And if we accept this scientific view, does it come with a package that we don't want? Or does it come associated with certain political views or so forth? And it gets kind of messy. So I hope that by the end of the conference, this is all sorted out. One thing that is relevant for our churches, though, is that according to Christian scripture, this whole cosmos we live in is both conceived and upheld by a living word, a person who relates to us in the presence and the spirit of Jesus the Messiah, or in Greek, Christos. And Hebrews points this out, that Jesus was not an afterthought, that in Christian faith, Jesus is the focus of the cosmos throughout all time and space, not some fix-it to come later. Hebrews says, in the past, God spoke to our forefathers through the prophets at many times and in various ways, but in these last days, he's spoken to us by his Son, whom he appointed the heir of all things and through whom he made the universe. The Son is the radiance of God's glory and the exact representation of his being, sustaining all things by his powerful word. So, nature, science, and the universe connect to Jesus Christ. That's a connection that isn't always made in churches, and it's kind of hard to make, but it's there in Scripture if you look. And there is our beautiful planet Earth that we live on, and there are some tough questions. It's not all beauty and majesty, and I don't have time to answer these questions because I can't answer them, so I'll just throw them out. Why such a long time for the universe to develop while life has only been around, it appears, for a small fraction of that time, and yet the period of time emphasized by the Bible, in other words, recorded human history, is only a tiny fraction even of that? Good question, huh? And what was God doing all that time? Was it important? And what will the long-term future of the universe hold if we keep expanding and accelerating in the cosmos and all that? And there's more. Why do those same processes that we need to form the creation and even sustain healthy conditions for life? For example, we understand now that it looks like plate tectonics on our own planet and volcanoes are processes that help recycle our atmosphere and give us a living planet, unlike places like Venus that don't have plate tectonics and the atmosphere grows stale and greenhouse gases take over. Those are wonderful things. Aren't we grateful for earthquakes and volcanoes? Why do these same things cause such pain and death and grief? How do we handle that? And what about what creatures, including humans, do to other creatures? This is the whole problem of suffering and evil, but it is something that has to be grappled with if this is God's universe. Is this okay? As I was preparing this talk, there were many news stories of what humans do to one another, but also this story that was just one little sidebar of elephants in Cameroon that were minding their own business when people, armed people came from the neighboring country, gunned down 300 of them, took only their tusks, waited for the grieving elephants to return to mourn their dead, because elephants have deep family ties. They grieve for one another. They came back to grieve their dead, and they were gunned down too. Why is this allowed in nature? You know, the cosmos has grief and suffering, and we have to figure that out. We have to understand that. We do know that in Christian theology, God has not ignored suffering, but entered the world and experienced that suffering with us. And finally, I'm going to close that we recognize the beauty of nature and are drawn to explore. So perhaps that implies, as we're looking for ways that the heavens declare the glory of God, that God enables us to desire to explore and grow in understanding of the natural world. This could be a facet of God's love. We explore with astronauts. We explore in every way we can. This is a student who's visually impaired, who is feeling the different textures in this textile encoded image of a nebula, much the same as you've enjoyed seeing with your eyes. She's seeing it through her touch and being every bit as full of wonder and excitement about viewing the universe. This is a beautiful image of the Horsehead Nebula, just released a couple of weeks ago from the Hubble Space Telescope. And through this ethereal image, made in infrared light, so we would never have seen it quite this way without infrared cameras on the Hubble Space Telescope, we can see something of the majesty of God's glory. I'm going to skip over the resources here, but I want you to understand, especially this organization, the American Scientific Affiliation, is a network of Christians in science that I think many of you might be interested in. Carl Sagan said, "Who are we? We find that we live on an insignificant planet of a humdrum star lost in a galaxy tucked away in some forgotten corner of the universe." That's one way of responding to this. There's no valid or invalid way of responding to what we learn through science, except that I think this is a better way, which is King David's way when the psalmist wrote, "O Lord, our sovereign, how majestic is your name in all the earth. When I look at your heavens, the work of your fingers, the moon and stars that you've established, what are human beings that you're mindful of them, or mortals that you care for them?" So he's feeling that sense of insignificance that we sometimes feel when we look at the heavens, when we look at the hundreds of billions of galaxies, we sometimes feel like we must be insignificant. And yet he made the realization that we can make, that God has chosen to give us significance. He says, "Yet you've made them a little lower than God and crowned them with glory and honor. You've given them dominion over the works of your hands. You've put all things under their feet." You've given us the earth as we look back at it from the space shuttle and see the fragile atmosphere, that cusp of light circling the earth shows us that our earth is fragile. We need to be good caretakers of the one planet we know for sure does harbor life. And I'm going to close by just saying that we should praise God for the universe, I believe, and praise God for the gift of science that allows us to explore and understand the wonders of creation. I gave a talk similar to this to a group of medical doctors, of women in medicine and dentistry, and one of these doctors went home that night, and she coined this paraphrase of a psalm, and she sent it to me, and I'd like to share it with you. It's called, "The Lord is my galaxy maker." The Lord is my galaxy maker, I shall not want for praise. He makes me lie down in green pastures and upwards look. He leads my gaze to behold his heavenly glory, and thereby he restores my soul. He leads me in colored paths of awe and wonder for his name's sake. Yea, though I walk through the valley of the shadow of death, I will fear no evil, for he is with me. His nebulae and star clusters and even their interstellar gas comfort me with assurance of his power and majesty. He prepares a tapestry of stars before me in the presence of my enemies. He anoints my mind with the joy of speechless discovery. My eyes overflow with tears. Surely hallelujahs and praise shall fill all the days of my life, and I will dwell in his celestial house forever. Thank you, Dr. Clydette Powell, for that beautiful psalm, and I thank you very much this evening.